So we are looking at the last section of chapter 1 and the last day of new notes for chapter 1, which means we'll be reviewing and then taking our test. So 1.6 trig functions. This is the last day of review material. After we take our chapter 1 test, we start chapter 2, which is limits. I'm very excited. You may be less excited. So, graphs of trig functions. On your handout in front of you, you should have the 6 trigonometric functions graphs and their domain, range, and period. So, those graphs, their domain, ranges, and periods are something you're going to need to know as we work through our problems, because they're going to be altered through transformations. So cosine and sine are the 2 most commonly used trig functions. Their domain and range is their domains for both are all reals, and then their ranges are the same. They go -1 to 1. That range of -1 to 1 is related to the unit circle. If you think about sine and cosine at an absolute max and min, the radius of the unit circle is 1. Therefore, the domain and range, the highest range point is 1, because the circle is only a radius of 1. The periods for sine, cosine, secant, and cosecant is 2 pi. A period means the cycle it takes to go around the unit circle. Tangent and cotangent are pi. It takes them less time to repeat their pattern around the unit circle. A function f of x is said to be periodic if there is a positive number p such that f of x plus p equals f of x for every value of x. The smallest value of the period is known as p for period. The functions cosine, sine, secant, and cosecant have periods in a regular cycle of 2 pi. Tangent and cotangent are pi. The period length can change with transformations. The period length can change with transformations. If you took physics this year or last year, Hooke's law is an example of a periodic function that has an oscillating type of behavior. Sine and cosine also sort of behave in an oscillating manner, and that's why their graph looks like a wave. The graphs of cosine and secant are even because their graphs are symmetric about the y-axis. The graphs of cosine and secant are even because their graphs are symmetric about the y-axis. That means if you plugged in x, you could also plug in -x and get the same answer. The graphs of sine, cosecant, tangent, and cotangent are odd because they're symmetric about the origin. We could show that the functions are even and odd by plugging in negative x and picking unit circle values and seeing that we either get a positive x if it is even or a negative trigonometric function if it is odd. I promise I hit change slides. Oh, there we go. So again, shrinking the graph for a trigonometric function is almost identical to changing a graph on a quadratic function. Outside is going to be your vertical stretch or shrink, as well as your reflection across the x-axis. Inside is going to be your horizontal shift, and outside will be your vertical shift. In order to find the period of a trigonometric function, you set the bx equal to 2 pi or pi, depending on what the period of the original function is. Or pi, depending on what. So sine, cosine, cosecant, and secant have periods of 2 pi. Tangent and cotangent have periods of pi. So if there's like a value in the next one where it's -2 sine of 4x, then what we're going to talk about is how these change. So it's reflected because there's a negative. It is going to be stretched by 2. So that's the A, or in trig terms, we call that the amplitude. The period, and this is where the setting equal to 2 pi comes into play. So the bx value is 4x. So that 4 is going to change the length of the period. So instead of taking 2 pi to get through one cycle actually occurs in pi halves. So what that means is this function is oscillating faster. So instead of it taking 2 pi lengths for a period to occur, it takes a pi half. So that means that this is 4 times as fast as the normal sine function. The horizontal translation comes from bx equaling negative bc. So it comes from bx equaling negative bc. So I got x equals negative pi fourths. So what that means is this graph is shifted to the left pi fourths. There is no up or down because there's no value at the end of the trigonometric function. So there's no vertical translation. This graph represents one cycle or one period. technically this graph continues infinitely in both directions. So if it takes from 0 to pi fourths, this would take from pi fourths to pi halves, etc., etc. So this would be negative pi halves, and so forth. The height is at 2 because it is stretched by 2. So you'll notice that this goes up to a height of 2. Maybe it's because it's on my hotspot. I think turn it off. Okay, so go ahead and look at the next example and write down what you think you know. So you should be able to look at that and determine the A value, because the A value is the amplitude or the value in front of the cosine. You need to distribute the 2 so that you can solve for your period and your horizontal translation. So you're going to distribute the 2, set Vx equal to 2 pi. Yes. Yes. It's set equal to pi because their period is different. Okay. We should be back on track. So the amplitude is 3. Your period is equal to pi. Amplitude is 3, period is equal to pi. Your horizontal translations would equal to pi halves, and your vertical translation is up 1. The amplitude is 3. Your period is 2x equal to 2 pi, or x equals pi. Your horizontal translation is 2x equal to pi, or x equals pi halves. And your vertical translation is up 1. Now, where the vertical translation comes into play is that instead of your graph now going from 3 to negative 3, your graph is going to go from 4 to negative 2 because everything gets bumped up 1. So instead of the x-axis being your key points are going to come from the line y equals 1. So your zeros that normally occur on cosine are now going to occur at y equals 1. So your max and min, or your range, is -2 to 4. So again, I said the range on the unit circle is -1 to 1. The range on this graph is going to be -2 to 4. And then it is going to be shifted pi halves. So what that means is that instead of the graph, which on cosine usually starts at 0, 1, your graph is now going to start shifted pi halves. And then instead of starting at 1, it is shifted up to 4. The period is pi. So what that means is that this graph is going to end pi after it starts. So if it starts at pi halves, it's going to end at 3 pi halves. So if it starts at pi halves, it ends 1 unit of pi later because the period is pi. So pi halves plus pi is 3 pi halves. So we'll end at pi halves, and it starts at an original height of 4. Again, 4, not 3, because it is shifted up 1 unit. Yes. It's positive pi halves because you have to move it. It's like setting the inside equal to 0. So you'd move the pi over and divide by 2. It's just like quadratics. Remember, everything inside a quadratic is the opposite direction of what you thought. So if inside the quadratic it was x minus 2, that doesn't take it to the left 2, that takes it to the right 2. So if inside here it's x minus pi halves, it doesn't take it to the left pi halves, it takes it to the right pi halves. This is actually your transformation right there. Just like the quadratic. The midpoint of pi halves and 3 pi halves is pi. So that is going to be the min, or the middle of cosine. So that means at -2. And then we know that the zeros of cosine happen in the middle of its max and mins. So in the middle of pi halves and pi would be 3 pi fourths and 5 pi fourths. And again, the zeros are going to occur not on the x-axis, but shifted 1 unit up. That is what they call a 5-point summary for a trig function. It is the 5 key points of the cosine graph on one cycle. Yes. By setting bx equal to 2 pi. Because the original period of cosine is 2 pi, but the 2x changes in making it a faster period. So basically it doubles its cycles. So instead of having 1 cycle from 0 to 2 pi, it would have 2 cycles. Just like we have inverses of linear, quadratic, and exponential type functions, we also have inverses for our trig functions. So once again, if you think about an inverse, the property of an inverse function is that the domain and range switch. So the domain is originally negative infinity to infinity, and the range is negative 1 to 1. Well, if you think about the fact that in order to have an inverse, it needs to be 1 to 1, meaning it passes the horizontal line test. This would not pass the horizontal line test if you would continue the cycles. So we have to limit the domain and range of the trig functions so that they pass the horizontal line test, just like you had to limit the domain and range of a quadratic to pass the horizontal line test. So the inverses at their most basic inverse changes are in this table above. So you can see how the domain of the inverse cosine was the range of the original cosine, but the domain of the original cosine gets changed to a slightly smaller range in order to account for the fact that cosine does this over and over again. It would not pass the horizontal line test. Here are the graphs of all the inverse functions. They don't even look like trig functions, but if you turn them on their side, you can kind of see how they would start to represent that inverse relationship. So again, if you kind of turn it on its side, you could see how it would represent that. Oh, that's technically on those images too. I just think it's a little blurry to see from there. Okay, so Brooke, this might even help answer your question you're asking me before about the even and odd. So we can find inverses similar to how the even and odd idea works. So it says find the measure of the inverse sine of negative 1/2. So basically this is like doing the unit circle worksheet we did yesterday in reverse. So now you're given the unit circle value and you need to find the value on the unit circle at which it occurs. So we know that sine is negative in quadrants 4 and 3. And we know that the sine of 1/2 occurs at pi 6. So the inverse sine of 1/2 is going to occur at pi 6. And then it needs to be negative. So it has to come from quadrants 3 and 4. So that's down pi halves from the x-axis. So you get 7 pi 6 or 11 pi 6, which is 210 or 330. Now, let's take out our graphing calculators. And I want you to see what happens if you do this on your graphing calculator and why it's so important for us to understand how it works. So first thing you want to do is we're going to do this once in degree mode and once in radian mode. So go ahead and put your calculator into degree. So in order to do that, you hit on, go to mode, arrow to the right, and go to degree. In order to get the inverse, you have to hit the second key. So you're going to hit second inverse sine. And then you're going to type in negative 30. Or sorry, negative 1/2. And you should get out negative 30. So again, negative 30 isn't on the unit circle. It's not from 0 to 2 pi. So in order to make it 0 to 2 pi or 0 to 360, you're supposed to add 360 degrees to that, giving you 330. So again, that would give you your point here in quadrant 4. That would not give you the point in quadrant 3. You need to know that all sine, cosine, trig functions come in opposite pairs, meaning there are always 2 of them. So you would have to have figured out that this also occurs here, which would be 30 degrees past 180, giving you the 210. Similarly, go ahead and turn your calculator now to radians. Hit second inverse sine. Type in that negative 1/2. Here's the problem. It gives you a decimal that we don't know. So this is why it's so important to understand your unit circle. So what happens if you get an example like this one? Is 0.7 a unit circle value? No. Guys, 0.7 is not a unit circle value. It's not root 3 over 2. It's not root 2 over 2. It's not a half, 0, or 1. So that's not a unit circle value. So what you need to do for this problem in radian mode is hit second inverse sine, put in 0.7, and we get x equals 0.7754. Is the sign value positive or negative? Positive, which means I need, or no, my answer had to come from quadrant 1 or 2. How do I know which quadrant my answer came in from? What are the values of the quadrants? So this is 0. What's the top represented by? Pi what? Pi over 2. Pi over 2 as a decimal is 1.57. 1. Pi as a decimal is what? Yeah, it wasn't meant to be like a trick. And then 3 pi halves is between pi and 2 pi. What's 2 pi? Yeah, you just got to double 3.14, right? So what's probably going to be in the middle of 3.14 and 6.28? You're pretty close. 4.71. So where does this 0.7754 occur? What quadrant? 1. Thank you. So it's hanging out somewhere over here, right? Where does the other sign positive value need to come from? What quadrant? Where other quadrant is sign positive? 1 and 2. So it needs to come from over here. So if I'm going from the x-axis, is that going to be larger or smaller than pi? Is that number going to be bigger or smaller than pi? Smaller, because it's going to happen before pi, right? So in order to get this value, you have to take and say x equals pi minus 0.7754. Because the other value always comes with respect to the x-axis. So this is kind of like 0 plus 0.7754. This will be like pi minus, because we want to go backwards. If I wanted to get into this quadrant, what do you think we do with the pi in that number? Ah, good, I heard it. Okay, so then this is pi minus, or 2.366. Tangent equals -2. Tangent equals -2, and this is important. How does this change from that? So go to your calculator, do second inverse tan, -2. Not a unit circle value. We don't really have a tangent equaling -2 on our unit circle, so we know that we need to find this. So you're going to get x equals -1.107. Are there any negative numbers over here on my unit circle values? No. So if you get a negative answer, you have to take and add 2 pi to that. So then I get 5.176, which occurs in quadrant 4. So if this is occurring in quadrant 4, then the other point occurs across from it, because tangent is positive here and here. So if tangent's here, it's negative, which means its other point occurs over here. So that is a straight line, which would be like kind of subtracting 180 degrees, but we're in radians, so 180 degrees in radians is pi. So it would be x minus pi. So it'd be 5.176 minus pi, or 2.034. But this doesn't want to know just the unit circle values. It wants to know on the entire x domain, which means that these two values occur every 2 pi k, where k is an integer. So you have to pay extreme caution to your domain and range. Here, it only wanted the ones on the unit circle. This one wants the ones in the entire domain. So the original point you get when you do it on your calculator gives you quadrant 4. So because tangent is all students take calc, the other point needed to occur in quadrant 2. So quadrant 4 to quadrant 2 is 180 degrees difference, or a pi. So we take our answer and we subtract pi from it to get the 180 degree difference. Okay, I think that's corrected to match what I put on your paper. Maybe not. Actually, the original was on your paper. Ignore this. Go back to that.